Hello and welcome to Engineer's Mindset. Now I will be taking you through trigonometry, but before we carry on any analysis on trigonometry, let us understand the right angle triangle. This is a good example of what a right angle triangle looks like. This longest arm is called the hypotenuse arm, so we'll call this hypotenuse. Meanwhile, side AB and side BC are all adjacent. They are only adjacent when there is no angle. But when we introduce an angle, then we'll have what is called the opposite and the adjacent. At this point, AB and BC are adjacent. But let me say I introduce an angle here, say theta. If this angle is here, then this side AB that faces the angle becomes what is called opposite. So the side directly opposite the angle, the side directly facing the angle is called the opposite. Meanwhile, the side that is not facing the angle, since we have an angle here, the side not facing the angle is what we call the adjacent side. Okay, so like I said, if there were no angle, then the both arms are all adjacent. But since there's an angle here, this side that faces the angle directly is called opposite. Meanwhile, the side that is backing the angle is called the adjacent. So that means that if I have a new right angle triangle, let's say I have a new right angle triangle and okay, A, B, and C, this remains hypotenuse. It doesn't change. So let's now say I have my angle at this point. So notice that there's now a change in position of the angle. So it means now that side BC is directly what? Opposite to the angle. So this is now called the opposite arm. And this is called the adjacent. The side that is not facing the angle is what we call the adjacent side. Meanwhile, the side that faces the angle is called the opposite arm. Okay? Now, there are basic things we need to know in trigonometry. First of all, let's talk about trigonometric theorem. Okay, so let's talk about the trigonometric theorem. The trigonometric theorem states that the square of the hypotenuse arm, which is A to C, is equal to the sum of the square of the two adjacent sides. Now, notice that there is no angle here. So since there's no angle, these two sides becomes the adjacent. So the theorem is simply saying that the square of the hypotenuse, so A to C is the hypotenuse arm. So the square of the hypotenuse arm, AC square, is equal to the sum of the square of the two adjacent sides. So AB squared plus BC squared. Okay, so this is what the trigonometric theorem is all about. So this means that if I am given a problem, let's say I have this problem and my side, let's say here is A, B, and C, and I have there to be 3 meters and I have there to be 4 meters. And the question says find AC. AC happens to be the hypotenuse arm. So we can use this theorem to find the value of AC, knowing that AC square, according to the theorem, is equal to the sum of the square of the two adjacent sides is AB square. Meanwhile, A to B is actually 3 meters. So this is actually 3 squared plus, and then B to C is 4 meters plus 4 squared. Okay, so AC square is now equal to 3 squared is 9 plus 4 squared is 16. I have AC squared to be equal to 4 and 9 plus 16 is actually 25. So it means now that AC, for me to obtain AC, I have to take the square root of both sides. So I have to take square root of both sides. So that's now equal to square root of 25. Okay, and therefore AC is simply 5 meters because the square root of 25 is 5 meters. So that's what the theorem is saying. The square of the hypotenuse arm is equal to the sum of the square of the two adjacent sides. So if I am given any adjacent side and I'm asked to find the hypotenuse side, this is how I apply this theorem. This trigonometric theorem is what we call Pythagoras theorem. It's called Pythagoras theorem. Okay, all right. So let's try another example and see. Okay, so let's say we have another example, and here is let's say 7, and this side is let's say 5, and of course we are asked to find portion BC. So question will say find BC. Okay, so to do this, it's still the same thing. I told you A to C is the hypotenuse arm. The longest arm always represents the hypotenuse arm, and from the Pythagoras theorem, AC squared is equal to AB squared is plus BC all squared. Okay, so we are asked to find BC. Already AC is known as 7, so in place of AC we'll have 7 squared equal to, we'll have AB squared, and AB is given as 5, so 7 squared equal to 5 squared plus BC squared is unknown, what we are looking for, so plus BC all squared. All right, so 7 squared is 49 equal to 5 squared is 25, okay, plus BC all squared. But we are looking for BC, so what we do is to send 25 over to this side of the equation. If 25 crosses an equal to sign, remember this is plus 25 and not minus, so if positive sign crosses an equal to sign, it becomes negative. So we have 49 minus 25 equal to BC all squared. Okay, let me divide. Okay, so therefore, continuing from here, it means now that that implies that BC all squared is actually 49 minus 25, and 49 minus 25 is 24. Therefore, in order to find BC, we take the square root of 24. So that implies that side BC is equal to square root of 24, and therefore BC is equal to, BC is 4 points, approximately 4.90 meters. All right guys, let me take you through another example. Okay, so let's say we have another triangle, okay, with sides. The hypotenuse arm is 8, this adjacent side is 4, and we have AB unknown. So let's say we have to find AB. Okay, so to do that, also apply the Pythagoras theorem. So applying the Pythagoras theorem, as usual, the sum of the square of the hypotenuse arm, which is C squared, is equal to the sum of the square of the adjacent side, so AB squared plus BC squared. So AC squared, which is the hypotenuse arm, is given as 8. So you have 8 squared equal to AB squared is unknown, so we'll have AB squared unknown plus BC squared is 4, so which is 4 squared. So 8 squared is 91 equal to AB squared unknown plus 4 squared is 16. As usual, send 16 over to this side of the equation. This is now plus 16, so plus crosses an equal to sign, it turns automatic negative. So you have 81 minus 16 to be equal to AB squared. So this simply implies that AB squared is equal to 81 minus 16, and that is 65. So in order to obtain AB, we take the square of 65. Okay, so that simply implies that AB is simply the square of 65. Okay, and therefore AB is equal to, and that's approximately 8.06 in meters. All right, that's it guys. The next thing we'll talk about on trigonometry is going to be trigonometric identities. Okay, for now, so the next one we'll talk about is trigonometric identities in the next video. I will see you in the next video with that. Thank you.